today. Let's do it. Chi-square two-way tables, and we'll just go from this first example, and I'll kind of talk to you about how do we get it into our calculator, how do we make our calculator do a lot of work for us on this one right here. All right, ibuprofen, acetaminophen. It says in a study report at Annual's Emergency Medicine, researchers conducted a randomized, double-blind clinical trial to compare the effects of ibuprofen, acetaminophen plus codeine, a pain reliever for children recovering from heart fractures. There are many response variables recorded, including the presence of any adverse effects, such as, and they give us the adverse effects, but they give us the two-way table. This is going to be a true indication. Should I be doing a chi-squared test, a two-way table test? If you don't see a two-way table, you're probably not doing a two-way table test, right? They're always going to present it to you as a two-way table. Okay, so the question says, determine whether or not the sample provides convincing us that ibuprofen and acetaminophen give the same adverse effects. So I'm just going to highlight this right here. So when I see the word same, I know that we're going to be running a test of homogeneity, because that's the word, right? That's that word connection. Homogeneity means the same. And so if I see that, it's going to be very much like a goodness of fit test. It's a big, giant goodness of fit test for a two-way table on this, okay? So that's going to be the first kind of indicator that I want to find. Anything that lets me know, am I doing homogeneity or is there some kind of independence test that I'm running? So let me do this, and again, this will be linked into the syllabus so that you can go back and look at this. But if you want to write this down as an example, we're going to go through the entire phantoms on this problem, and we'll do phantoms on the second problem, just to give you the idea of what it looks like here. Okay, number one, null hypothesis, right? What does it look like? Since we are trying to see, do they give the same adverse effect, then my null hypothesis, we are going to use the word same in it. You always use the null hypothesis to be the same. Very similar to like it was with the goodness fit, right? We would say that the outcomes are the same as what they said they would be. So on this one, and I'm just going to use words. We're going to go away from the actual like showing numbers in here. But we would say that ibuprofen and acetaminophen give the, and I'm just going to highlight this, same adverse effects. And so if you need a little side note, you can say the null hypothesis will always have the word same in it, right? That's kind of your side note. Ibuprofen, acetaminophen give the same adverse effects. Alternatively, we're just going to repeat it, and instead of saying the same, we're going to say different. So we got the same and different. So that's literally, if it's a homogeneity chi-square test, that's what it'll look like. You use some contextual words, but otherwise, always use the word same in the null. Always will use the word different in the alternative hypotheses. Okay, so that's probably the hardest part, is really like just thinking about, should I be using words like independent, associated, or the same and different, right? So it's just identifying what we're doing. Okay, assumptions and checks. There's always three assumptions and checks we always do: shape check, random check, independent check. So number one, shape check. In order to do a chi-squared check, this is the same one that we use for goodness of fit, it will work here as well. We need to make sure that all expected counts are greater than or equal to 5. All expected counts are greater than or equal to 5. So I'm going to have to stop and pause for a moment because I don't see any expected counts. All I see up there in that little two-way table is observed accounts. So everything you see here is observed. And I'm actually going to highlight real quick. It's really just these 4 values right here. Those are the true observed accounts that they saw. Here's what we saw. It's those. It's just the middle of that table. So here's what we're going to do is we're going to put those into our calculator. So in your calculator, let me slide to the side so I can show you what I'm hitting here. I'm going to go to my matrix button. So my matrix button is I would hit second, and then I would hit my x to the -1 button, which actually takes you to the matrix menu, right? So go ahead and do that second matrix. And then you're going to see some matrices listed on there, A, B, C, D, E, F, all that stuff there. But it doesn't matter what's in those. Slide over to Edit. So I'm going to go to Edit. I'm going to hit Enter. And then when we're in the matrix, so it's going to say like this. It's going to say Matrix A. And then it's waiting for you to type in. It might already have some numbers in there, but it's basically asking you to type in a matrix. Now you got to think back to advanced algebra, algebra 2, when we did matrices in calculators, if you did matrices in calculators back then. But a matrix is always rows by columns. In this one, we happen to be doing a 2 by 2 matrix, right? Because there's only 2 rows and there's only 2 columns. Do not put the totals in there, just the meat of it, right? It's a 2 by 2. And then let's put this in here, right? Again, it's don't put the totals in, just put the main part of it. So 36, 57, 86, and 55. So make sure they're in that exact same location though, 36, 57, 86, 55. So that is building our observed matrix there. Okay, so that's observed matrix. Let's talk about expected matrix. Expected, you don't even have to do as much thought on an expected matrix as you did with a goodness of fit. Goodness of fit, you had to go read, and you'd have to say, here's what they're expecting to see. In one of these two-way tables, there is a standard way to find your expected matrix. So if I think about expected, it still needs 4 different values here, right? So 4 different values. The way that you find those expected values for each of them, it's row. Here, I'll zoom in here. It's row total times column total divided by grand total. For each one, row total times column total divided by grand total. Here, and you would do the same thing here, you do the same thing here, you do the same thing here. And we're going to get all those different values. So I'll show you how to do it by hand, but the good thing is we don't have to do it by hand. Our calculator will do it for us, but I do want you to know how to do it by hand, especially if you're taking the AP exam. That's a very common multiple choice question. It's just how do you find a single expected count in any of these? So row total times column total divided by grand total. So if I was looking for the expected count of just this first one, I'm going to kind of subdivide this. I'm going to take its row total. So think about row total, which is 93, times column total, which is 122, divided by grand total, which is 234. So again, if I'm going to take this value right here, it's going to be 93 times 122 divided by 234. So I could do that by hand, right? I'm going to back out of this matrix real quick. If I did that by hand, 93 times 122 divided by 234, it's going to give me 48.5, roughly 48.5 right there. If I needed to do the next one down here, let's say I was doing this one, adverse effects. or no adverse effects, I'd take its row total, 141, times its column total, it happens to share the same column, divided by grand total, 234. So if I needed to do that next cell on there, 141 times 122 divided by 234. So this would be 73.5. That would be what we should have expected to see there. Right, so we're just kind of doing, and so I could do that for each of those cells, and that's totally fine, especially when there's only 4 cells I have to worry about, those 2 on the left and those 2 on the right. If it was a bigger matrix, right, if it was a 5 by 3 matrix, that's a lot to have to calculate. That's a lot to have to work through. So at some point, I don't want to do it all by hand. So I'm going to let the calculator do it. All right, so let's go back to our calculator right now and just talk about what exactly I would do now. Now that I have matrix A and I have it all set up, right? So then I have my observed matrix A kind of put into the calculator. From here, go to second quit, just get back to a blank screen. And then here's where I'm going to go from here. I'm going to go stat. I'm going to slide over to tests. I'm going to go find chi-squared test, not the GOF test, the just regular chi-squared test. Now, if you have even the newest calculators or TI Inspire, it might actually say chi-squared two-way table test, right? But you're looking for just the one. If it says a GOF, don't use it, not for a two-way table. So chi-squared test, hit enter. And then here's where it's asking for your observed matrix, it's asking for expected matrix, and that's it. It just needs 2 things. So my observed matrix, I put it in matrix A. So just make sure the observed says matrix A, right? Expected matrix, check this out. You don't actually have to create an expected matrix. You just tell it where you want the expected matrix. So I just always leave this matrix B. And then just go down to calculate. So literally pretty easy. It's literally put in the observed matrix, go here, finish it, and you pretty much are done with the calculation part of it, right? It's pretty much that easy to do that. So when I calculate that, here's what I get for real quick. Chi-squared equals 1.15. It says my p-value is 8.4 e to the negative 4, and it says degree of freedom is equal to 1. So basically, it gave you all the critical values right here. That's the stuff we need to know right there. We're going to fill it in here in a second. I'm just going to show you what is it going to look like on a full-on two-way table, Phantom's problem. But before I do that, let's talk about a little side note here. How do you find degrees of freedom for a two-way table? It's very similar to a goodness of fit test. So here it is. To find degrees of freedom for a two-way table, it is the number of rows minus 1 times the number of columns minus 1. Number of rows minus 1 times the number of columns minus 1. So that's one to just kind of keep in track. Now, unlike goodness of fit test, I didn't even have to know that because my calculator did it for me. Goodness of fit test, you have to know it because it asks you for the degree of freedom. But let's just have this written down. It's just number of rows minus 1. So there was 2 rows, minus 1 is 1. Number of columns minus 1. There was 2 columns, minus 1 is 1. Take 1 times 1, and you get 1. That's why it says degree of freedom is 1 there. Okay, so now that we have all this stuff, let's fill it all in, and let's pretend that we know what we're doing here, right? So half of like what we're doing for an AP test is letting our calculator do the work, but then coming back and filling in all the missing pieces. What are all the checks? What does the curve look like? What does the formula look like? All that kind of stuff, right? So let's go back to our A part of phantoms. All expected counts are greater than or equal to 5. Well, here's how I'm going to go check, right? Because I haven't actually seen that yet. So do this with me if you want. Go second. Let's go back to our matrix menu. X to the negative first. Let's go into our matrix menu. So math. Oh, no. second matrix menu. And instead of going over to matrix, just scroll right on down to matrix B. Just scroll down to matrix B, hit enter, and then this is what will show up on the screen. It'll say matrix B, hit enter. And it will produce for you the expected matrix, right? So it says 48.5, 73.5, 44.5, and 67.5. So that is the expected matrix when you're looking at that. Right? Why? The calculator produced it for you. You don't have to do it by hand. You are welcome to do it by hand, but you don't have to do it by hand. All right, so that's what it looks like, expected matrix. So let's go look real quick. Are all the counts greater than or equal to 5? Remember, it's always your expected, not your observed matrix. Yes, they are. So if they're greater than or equal to 5, I'm going to put a little check right next to it. Let me run the other assumptions real quick. Is it random? Randomized. So this is randomized. And you can either run the 10% rule, remember, or since it is an experiment, right? They ran a double-blind clinical trial. It's an experiment. We could always use the words assume individuals are independent, right? We want to assume that the individuals themselves are independent, not necessarily the variables. So that's what that looks like. Let's talk about the t. What does the t look like? Well, that is producing the chi-squared. That's showing the curve. That's drawing the curve, shading the curve. So here's what I always like to do on this. Oops, I didn't mean to do that. We always know the curve is going to be skewed right. Now, how severely skewed, we don't really know, and it doesn't really matter. We just always know it's going to be skewed right. So that's what one of the things I want to always show is that. I also want to start to show the formula, chi-squared equals. I'm going to start the formula. It's going to be observed minus expected divided by squared, divided by the expected counts. Where do I go find those? In my calculator and on what's already given to us. So what's the observed? I'm going to just look at the first cell here. 36 is the observed count. So I'm literally just going to write in here 36 minus, I'm looking at the expected count in my calculator still, 48.5 divided by 48.5 plus ... So this is really all you need. If you're doing the AP exam in about 2.5 weeks, right, is when that exam is, this is about all you have to show. So if you're going to do the data set problem during review day, or you're on the AP classroom and I want to see the full out, this is the minimal amount that you have to show. I know what the formula starts to look like, and I know it's going to continue on from there, and then it's going to produce whatever now your calculator said it would produce. All right, so it looks like it's going to be 11.15. Right, so there's chi-squared test. Now look at the p-value. My p-value is super small, so I'm going to put 11.15 here, and I'm just going to shade the tiniest bit of my curve, because the p-value represents how much of the curve you actually shade. Yeah. On an AP or on your exam, you want to write out the whole. No. Literally, just like even AP. This is good enough for AP right there. If you just show that. Exactly. You're basically saying, I'm using the calculator, but I'm telling you, if I needed to do it by hand, I can show you that I could do it by hand. Yeah. And that's kind of what the deal for AP exams is. They want to know that you can connect a formula back to a problem, essentially. And so that's all we're showing here. Yeah. So don't have to write the whole thing out unless you just are feeling overambitious. Then you can write the whole thing out. Okay, so there's our t. So notice I got the curve, I shaded the curve, I showed the chi-squared, right? That's always the 3 parts that you need for the t. Show the curve, shade the curve, show the whatever test statistic that you're doing, whether it's a z or t or a chi-squared. The O, obtain a p-value. Remember your p-value, we already know it's in our calculator. it is 0.00084, which is what 8.4 to e to the negative 4 is, right? So it's super small. So what decision do we make? Since they did not give us an alpha value, we get to make an alpha value. So I'm going to say this. I'm going to say reject null hypothesis at, I'm going to say alpha equals 0.01. I like to use small alphas when my p-values are really small, because that just still means I'm going to reject. And if I can reject, then I would say we have evidence to suggest that ibuprofen and acetaminophen give different adverse effects. Right, so the summaries, it takes a lot, like just put in all the context that you need to into the summary, right? So you're basically listing it right off of the problem there. But that's where people make their money in stats, is being able to interpret what it is that we say, right? So being able to do it, but then be able to tell it back to the person, be able to tell it back to a business, be able to tell it back to the science profession, whatever it is, right? We need to be able to interpret our results here. So that's why it's important to put that. So there's the full-on phantoms problem looks like. So the hardest part here was really setting up the hypotheses, right? Just trying to take the right words in there and figure out what we're doing for that one. Yeah. Yeah. The smallest sample size. Oh, okay. Yeah, so in that case, so that's like a goodness of fit and trying to find the sample size. I mean, if they knew that P1 was, let's just say it was 25, P2 was 25, and there's a third category that was 50%, then we would need to know that something times 25 would have to be greater than or equal to 5 every single time. So like if you took, well, let's just do sample size of 10, we know that the expected count would be 2.5, which would be too low, right? Because you need all of them be at least 5. So you'd want to bump it at least to like 20, right? So I think that's all they were really after, was just understanding that sample size matters on these. Okay, so let's do one more. Let's run through one more, and I chose a second one just so that I could show you that sometimes we just set up the alternative and null hypothesis with the word independent instead of the word same, right? And that's really the difference. Otherwise, everything else is in your calculator. So this will give you a chance just to practice calculator functions again real quick. But let's just say, so this one, it says Tide versus new Tide. So laundry detergent, they're bringing on a new product. They're going to call it new Tide, right? And so they're going to run basically ask people, what do they prefer? Which laundry detergent do they prefer, the new or the old? And what type of laundry practice do you do, right? So each person gets to kind of rank themselves in here, right? So this is a single sample. Instead of multiple samples, we have a single group of people, and they got to kind of rate themselves. So we're trying to figure out, does your preference on which laundry detergent you use and the type of laundry practice that you do, are they independent of each other, right? So is there a dependency between, oh, the people who like the new stuff all happen to be this style of laundry washing type people, right? So it just says, determine whether or not the sample provides convincing evidence. Anytime I hear convincing evidence, I'm thinking phantoms, that the preferences are independent of each other. Independent. There's our word independent. That's going to clue me in. So even before I put this in my calculator, let me just set up the null hypothesis and alternative hypothesis. And then we're just going to go for it in our calculator. Null hypothesis. You always use the word independent in your null hypothesis when we're talking about an association independence. So here's what it would sound like. Laundry practices and product preference are independent of each other. So just like with homogeneity, you could put a little side note here and say you're always going to use the word independent in your null hypothesis, right? That's always the word you'll see. Or, you know what the other name for independent is? Is not associated. So you could say the word not associated. That's what independence means, is that one can happen without the other, right? Not associated. Alternatively, laundry practices and product preference are dependent. So dependent. Or if you like to use the words association, I'm going to use the word associated. Okay, so technically the null hypothesis independent, alternative hypothesis is dependent every time. Or if you want to use the words association, we're going to say null hypothesis is not associated, alternative hypothesis is associated. And that would get you to what we need. Okay, if you haven't already, take your calculator. Let's put this matrix into our calculator. All right, and we're going to run a chi-square test. So see if you can go through all the steps right here. Let me make it nice and big for you so that you can see those numbers there. Let's put this into your calculator, just the practice of putting it in and letting our calculator do its work. So it is a 2x4 matrix. Oh yeah, you are doing. Oh yeah, you got the Inspire there. So you're gonna go to a matrix menu.
Okay.
So yeah,
this is kind of this is like the whole one.
Yeah, I'm trying to remember. Yeah, so go to, maybe it's under algebra. Oh no, matrix and vector.
Oh, that makes sense.
And then create.
Create. Just matrix.
Yep, matrix. On this one, yeah, let's call it a 2x4.
2 rows, 4 columns. I could not figure this out yesterday. And that's it.
So yeah, I'll go ahead and type that in, and then I'll take you to the next step.
Okay, perfect.
On that. All right, so see if you got those. Hopefully you got those. You know where to get that stuff from. So then everything else is the same, right? Identical, right? Look in it, put your formula together. Everything else, run it from here. But I can tell you right now, based on this chi-squared and that p-value, I will fail to reject the null hypothesis. That is such a big p-value. So you get to pick your alpha value on this again, but if it's 10%, fail to reject. 20%, fail to reject, right? It's such a big p-value. So then we would say we do not have evidence to say that they are dependent of each other. So we would rely on the statement that, yes, we believe that laundry practices and product preference are independent of each other. Okay, so that's what it looks like. And I know I'm leaving off all the assumption checks and stuff like that, but I believe that hopefully just doing it once, you have a pretty good idea what's happening there. So with that being said, let me just make sure that I have everything uploaded for you guys, and then Just let you guys work and ask questions as needed.